In this video, I'll show you how to use z-score to find the area under a normal curve. This is part 2 in the series. The question reads, suppose that the heights of 2,000 students have a mean of 176 centimeters with a standard deviation of 8.1 centimeters. So 176 represents mu, which is this Greek letter, and our standard deviation is represented by sigma of 8.1. Assuming the heights have a normal distribution, predict the number of students that are A, shorter than 165 centimeters. So I'll highlight some key terms here. Taller than 178 centimeters, between 165 and 178. To do this question, we'll need to calculate the z-score. So for A, we have an x value of 165. The formula we'll be using is shown here, where x represents the score, mu represents the mean, and sigma represents the standard deviation. So substituting 165 into our formula minus the average of 176 over the standard deviation of 8.1 will give us our score. Using our calculator, 165 minus 176 divided by 8.1 gives us a score of negative 1.35, or simply negative 1.4. So what does negative 1.4 mean? Well, take a look at your normal curve. This is our average. Negative 1.4, given that it's negative, means that this z value occurs to the left of the average. So what we can do is locate the absolute of this value, 1.4, from the chart. And 1.4 has a value of 0.4192. Negative 1.4 should be somewhere along here. And the area from here all the way to the mean is 0.4192. So I'll just draw in the area. Now the question is asking us, remember, shorter than 165 centimeters. So they want this shaded area. And I know that from here all the way to here is 0.5. So if I call the blue part, which is the part I'm looking for, A, and the orange part B, I can simply find the blue part by using the following formula. A plus B is equal to 0.5. So I'll substitute what my B was, and I found it to be 0.4192 into here. 0.4192 plus A. Solve for A, and I end up with 0.5 minus 0.4192 is equal to my answer. 0.5 minus 0.4192 gives me 0.080. 0.080. What I have to do with this number is multiply it by the amount of students that were surveyed, and that was 2,000 students. So this percentage, essentially 8% of 2,000 students, is equal to, so I take this number now, multiply it by 2,000. This gives me 161.6 students. But since you can't have part of a student, we'll simply round this up to 162 students. In question B, they want us to find taller than 178 centimeters. Once again, we need to calculate the z-score. So I'll say z, and I'll call this part A and this part B. Z is equal to 178 minus 176 over 8.1. Now using our calculator, we have 178 minus 176 divided by 8.1. This will give us a z-score of 0.246. 0.246. And I'll round this down to 0.2 for the sake of simplicity, and of course our table ranges to 1 decimal place, so we don't want to go beyond 1 decimal place. Now I'll take 0.2 and display it right here. That should be somewhere along here. And if we use our chart for 0.2, we'll end up with 0.0793. So I'm going to highlight this 0.0793. So this represents 0.0793, but they're looking for those that are taller than 178, so they're looking for this part. Using the exact same logic as before, I'm going to take 0.5 because that's the area from here to the end, and subtract it from 0.0793 using my calculator. 0.5 minus that number. This gives me 0.4207. So nearly 42% of the students are taller than 178 centimeters. I'm going to take this value now and multiply it by 2,000. That will give me an exact amount of students, which is equal to 841.4. So 841 students are taller than 178 centimeters, those that were surveyed. Now for question C, they want us to find between 165 and 178. To do this last question, I'll just use information that I found out earlier. They want us to find out between here and this part. That's not hard to do. All I have to do is add up the areas from here all the way to here, and then multiply by 2,000. So I'll take 0.0793 plus what I found out for B earlier, 0.4192, using my calculator. 0.0793 plus 0.4192. That gives me 0.4985. 0.4985. Multiply that by 2,000, and that gives me exactly 997 students. And so there you have it. That is how to use z-score to find the area under a normal curve.